welcome to the channel. So basically, based on this, you can guess that I managed to get the electric motor and the frequency converter slash ESC for the Autonomous TRX-6. I ended up getting this XeRun, Hobbywing XeRun brushless system combo. Looks like this. Okay, there's only manual here. Already opened it up, so a bit boring. Unboxing, just showing the box. No unboxing. Really. Okay, here's, I also got an extender for the sensor cable and the other cables, this kind of stuff, since I have no idea where I'm going to put it there. Here's the motor, brushless, axe, fork, the R2. I took the 540L, 2800 kVs. And then this is the ESC that all of them come with 80 amps and something like this. Okay, now I need to open them up. Let's open this one up. So this is the motor. Yeah, already opened it up too. To be honest, I rarely have patience to not unbox it. And that's the quickest unboxing in the world. I can't, if I see a box, I want to immediately open it. I don't have a good patience in that. And there's so many unboxings of these in YouTube, I don't see the point in that one, but now it was unboxed. Let's do the other one, this one. Oh, unboxed. Really quick unboxing. So, yeah, anyway. What's my impressions on these? Why did I choose these? Well, I like that they were advertising this as IP67 rated. Well, this electric motor seems like it, which is a good thing since it's going to be exposed to just about everything. Nice brushless motor, seems well made, bearings feel kind of okay-ish. Yeah, sensor cable there, sensor behind, as it normally should be. And here's the frequency converter ESC drive, depending on which field of engineering you're asking, or the hobbyists. I would call this a drive, or this is a drive package. This is a frequency converter with some controller in it, although it's quite limited to the features which I'm usually used to in robotics and many other vehicles and so on. So it's very simple, but basically the same stuff inside. I mean, there's a lot of configuration here, but not even close to what you can have in some professional equipment. Oh, but this is, I don't know if it is a lot cheaper than the ones I use normally in robotics. A lot cheaper. Now I got an adapter. Here's cables. So I noticed that the kits had, this is always the same thing, and I guess in some pictures they just show it without this fan. You can unscrew it, and then the combos depend which motor you take. They have the different kV values. Okay, now prepare for a rant. So people are choosing these based on, at least on the forums and YouTube channels I was watching, based on really weird criteria and beliefs about electric motors. I've been buying, designing, using not electric motors themselves, but drives and electric motors for all kind of robotic, all kind of applications for quite a long over 20 years, way over 20 years. And I have a certain set of selection criteria, which is from the datasheet of the motor, which I look through when I choose an electric motor for a purpose. I can calculate, measure, make it suitable for the purpose. Problem is that there's only like a small fraction of the information which is available for any of the commercial brushless motors which I use, independent of the size. Large, really big ones, many kilowatts, or really tiny ones, microscopic ones. I have massive amount of data out of them, which I can reliably use in defining which size and what I'm going to choose. This one, absolutely nothing. Completely pointless in that one. The same with this one. The information about this is not sufficient to say much anything about the performance. It's completely useless. This KV thing here, I was trying to figure out online, is there a different meaning for this KV in RC world? If it's not, this would refer to the ratio between the no load speed and the input voltage to the motor. And the thing is that people say it will go that fast. It won't. It's no load speed. The sooner you attach this to transmission and your car, it will not reach that speed, unless you have a car made with zero weight. So from this you can calculate basically things like torque constant, but again, it doesn't really help much. And the other thing is that the faster you go with this, the less torque you have. So, and the motors like the 5000, 3300 and so on, it's got different type of coils, basically what's inside, just that you can have slightly more speed. It doesn't mean that you have any more torque between any of these motors. What's the downside of it is having the 3300 is you have the bigger axle. I don't know why. It doesn't matter anything in the higher speed. If you don't have almost any torque left when you go full speed, doesn't matter. When people say why you don't have torque at full speed, well, it's laws of nature. You input certain amount of power here. The power can be concluded as a multiplication of voltage and the current. So if you have higher voltage, you have less current and vice versa. Understandable. But the power stays the same, which is the maximum power that this one outputs. And all these devices, motors, have the same ESC. So basically, unless there's some communication going through the sensor cable between these, that the programming of this one somehow limits the performance of this per model, this one outputs the maximum, same amount of power to every one of these. So it doesn't matter what you have. If this one outputs only certain, this is not going to add anything more to it. Energy doesn't come from zero. Okay, let's continue with the rant. So what was the other problem I noticed with this one? If the power is like voltage multiplied or the load multiplied by the current going through, fine. The other equation for power which can be used is power equals to torque, Newton meters, multiplied by the velocity. I think the rotational velocity, I think that was in radians per second, the official unit. And again, it's multiplication. If you have the same amount of power, then if you increase torque, you need to have less speed. If you increase speed, you will have less torque. There's nothing else coming there. And there's the fun part that also when you go to really low speeds, like almost basically a stall, meaning there's a force in trying to push the car backwards and this one is not moving, it's trying to keep it still. That's one of the most difficult situation because often then the cooling in these fails completely. Many motors, if they have a rotating fan, it stops and it's not cooling and the motor burns. It's very heavy, and when the motor overheats, it destroys the magnets here and loses all the torque. So even if you have the 3000, 2000, whatever, this tells more about the top speed of the motor. It doesn't tell anything about the torque. These are pretty much the same stuff. And I mean, of course, there could be differences in the torque inside the motor. But the problem is, one of the big problems is that the manufacturer doesn't give out any of the values which normally I would expect to get when I buy any kind of electric motor. They don't provide any information. So saying one way or another doesn't exist. But however, from the point of view of the power, based on the specs they give one nominal current, meaning continuous current, and one peak current, and that's it. and there's a certain voltage. Like if you have whatever amps here multiplied by the voltage that goes in and out, that's it. That's the power. That you have to divide between the speed and the torque. That's all you're going to get. Doesn't matter what motor you have. There's no magic energy pixies coming out. The second one is when you attach this to power transmission. Here's battery. Battery has own initial losses. Losses go there. There are losses, energy losses in this device. They lose something. There's energy losses in the electric motor, definitely. Then there's energy losses in the transmission. Energy losses between the tires, and the ground. There's losses everywhere, so you're not going to get the full power anyway. And that all adds to the load, which you're going to have reducing from the maximum speed. So it goes faster. But again, people wondering like, oh, I have this heavier machine. People are wondering why I put my like 550 whatever, or 350 whatever, it's the next one, onto a car, and it doesn't move so fast. Mine goes so fast. Well, it's also to do with the weight of the car. So like I said, the less torque you have used at your disposal, the higher speed you go with the motor. So basically, if you have a lot more load, you're not able to, the torque goes just moving it and accelerating. You're not able to get to the high speeds. There's too many losses in the way. So it's about the whole power transmission line, not just these two pieces. What else? This is what I'm wondering, like they're leaving these out saying waterproof. Okay, I'm interested in seeing how waterproof this really is. It could be just inside. They recommend in the manual you can leave this out if you're not using the 3300. And then they say that you should weatherproof this somehow, all of this. And these are not. So I guess I'll just use my liquid electrical tape. No screw attachments to the bottom, which is a bit of a disappointment, just a piece of scotch. Yep. I'm a bit suspicious about their claims. I have to say, the connector is for once a good one. This is really getting to correct direction, like I would say normal motors which I use in things. So this is good. I have to raise my hat. They've definitely seen effort in this one. And I'm quite sure that once I use, I will be very happy with the waterproofing everything performance of this one. It looks to be really high quality made. It's just more about the design choices. Everyone that's things with stickers. Whatever rocks your boat. But what they could do is end the kind of endless forum discussion about what motor is the best, has the highest torque. They don't provide half the information anyone to be able to calculate that. So sorry, I did an Excel sheet and trying to understand. And my truck will be really heavy, so it's not going to reach very fast speeds anyway. And another thing is that with a digital connection between any parts, like from people were saying that you can adjust the curve from the transmitter. It's true of how fast the speed goes up, but it doesn't change the fact that there's still a limited amount of bits or possible values going in the signal cable to the ESC. Which one it is? Maybe this one. There's only a limited amount of values that can signify a certain amount of speed. And it's valid for all of these systems. So when you have the higher speed you have, basically the higher speed has to be divided with the same amount of possible controllable values as with a smaller one. So when you have a smaller one, each step in your controller basically is a smaller step. So you get finer grained control of your speed. You lack from the higher speed, but you will the same amount of possible values to control are now just put into smaller area. So that's why I also chose this. I was thinking about the 3300, but then I realized axle, this one is correct size, don't need to bother with anything else. Can have smaller sprockets. Doesn't really make a ratchet in this configuration. Having a bigger like I said, the torque, it's not really that it's no different. It's defined by this here. Unless there's a hidden reduction gear here, which I doubt. I doubt it. This one, yeah, and I did some calculations and comparing the different, and from my application point of view, there's not different. I took it with this one. I was originally thinking about getting one of the smaller ones, just to get maximum resolution, like as small steps as possible for the controlling of the speed. But then I'm like, okay, I also might want to be interesting to see how fast I can run. Anyway, it's going to provide the same torque near zero speed, all of them. It's only depending on how you program what this one does, nothing to do with this. At least based on the information they give out of this device. But this defines the power, what you have available. You can choose either speed or torque. That's it. How this will overload, I don't know. Are these the cooling fins? I've burned a lot of small motors and big ones, really expensive ones, and the magnets just, you don't need to overheat this much, and the magnets die, and then it will not work. So that's the big problem. The second one is the stall torque, and because when you have a brushed one, you can kind of create a continuous current into the motor that will prevent the rotor from moving. It's much more efficient and better at stall torque. When you come to brushless ones, it's more difficult to create. So I'll lift my hats for Hobbywing if they manage to get it like they showed in many of the YouTube videos. One thing though, if you try to drive this forward and push the truck backwards, then it's probably possible that this will burn out. That has happened often to me. So it's fine when it's rotating, when it's resisting and trying to stay still, but when it's forced against its own torque going to the other direction, that's when it usually overheats. Let's see how it goes with this one. But that also depends so much on your own conditions when you're driving and so on. What else I have to rant about this? I have to say I'm really excited. I was thinking the Kyosho ones are nice. This is also very pretty. With the only thing lacking that they don't give enough information about any of this. Maybe they just want people to fight at the forums. What else? I think next video will be about installing this in place. And I noticed that the front axle housing from Treel had finally arrived to local post office, so hopefully I will be installing that too, and then we can go outside to, well, bash the hell out of this. I am planning to drive this through a really steep hill and for a lot of vegetation, because I need to see how it will do. Okay, next video about putting these into the car. See you, put thumbs up and like if you want or something like that. I don't know. Okay, subscribe, like, thumbs up, whatever. Next video will be about this. And that won't be a rant, hopefully.